Hello everyone. In this video, we will cover the recursion formula for the complete expectation of life and the n-year temporary expectation of life. If a problem indicates that mortality follows a certain form from hx to hx plus n, and then takes another form after hx plus n, then we can make use of the following recursion formula to compute the complete expectation of life for other ages. The left-hand side is the complete expectation of life at hx, and then the right-hand side of the recursion formula. This equals the first term. This is the expected future lifetime for the first n years. That is the n-year temporary expectation of life, plus the probability that the individual can survive up to hx plus n. The probability is npx, and then times the complete expectation of life at hx plus n. So this is the recursion formula. To derive this formula, we start with the definition of the complete expectation of life, split it into two terms, the integral from 0 to n, and then the integral from n to infinity of tpx dt. The first term is the n-year temporary expectation of life. And then the second term, factor the tpx into the product of npx times t minus npx plus n. npx is independent of t, so we can factor that out. And then by the change of variable, the integral becomes the integral from 0 to infinity, and then the variable is y, ypx plus n dy. So this integral is the definition of the complete expectation of life at hx plus n. So we get the recursion formula. For n equals 1, the terms 1-year temporary expectation of life is the integral of tpx dt evaluated from t equals 0 to t equals 1. And then from this, we can get the complete expectation of life at age x plus 1, x plus 2, x plus 3, etc. And then we can also have the recursion formula for the n-year temporary expectation of life. So this can be split into two periods. The first m years, which is the m years temporary expectation of life, and then plus the probability that the individual can survive up to hx plus m. The probability is npx, and then times the n minus m temporary expectation of life, which is the remaining years from hx plus m to hx plus n. And here we have this recursion formula. All right, so let's apply these formulas with a series of examples. Let's revisit the example that we have completed previously. Okay, given that mu30 plus t equals 0.01 when t is between 0 and 10, and for t greater than 10, the force of mortality is 0.02, and then compute the complete expectation of life at age 30. All right, make use of the recursion formula. So we have this expression. The complete expectation of life at age 30 equals to the 10-year temporary expectation of life starting at age 30, and then plus 10p30 times the complete expectation of life at age 40. All right, the 10-year expectation of life. So this is the integral of tp30 dt from t equals 0 to t equals 10. We need to get the expression for tp30, which is e to the power negative of the integral of the force of mortality. Okay, t is less than 10, so the force of mortality is 0.01. And we get tp30 equals e to the power minus 0.01 times t. And we get this value. And then the next term, 10p30. So we simply substitute t equals 10 into the TP30 expression, and we get e to the power negative 0.1. And then the last term we need to get is the complete expectation of life, E40. This is the integral from t equals 0 to infinity, TP40. We need to get an expression for TP40. All right, TP40 equals e to the power of the negative of the integral of mu 40 plus s. And we are given mu 30 plus t for t greater than 10. This is a constant, 0.0 t. So mu 40 plus s is a constant, corresponds to this 0.0 t, 0.02. So we get TP40 equals e to the power negative 0.02 t. Substitute into the E40 expression, we get E40 equals 50. And then plug all the quantities into the recursion formula. We can get the complete expectation of life at age 30, which is 54.7581. All right, and then the next example. Given 3 temporary expectation of life at age 60, the 4-year temporary expectation is 3.6. And the corresponding 10-year temporary expectation of life is 8.0. And then the 6-year temporary expectation of life at age 64 is 5.0. And we are asked to compute 4Q60. All right, make use of the recursion formula. Start with age 60 until 70, because we are given a 10-year temporary expectation of life. So this is from age 60 to age 70, the expected lifetime. And then we are given the 4-year temporary expectation of life at age 60. And then after the individual survive up to age 64 with probability 4p60, and then we can multiply with the 6-year temporary expectation of life. All right, so we can link up all these quantities into this recursion formula. And we are asked to find 4Q60. That is, we need to get a value for 4p60, and then we can get 4Q60. So we get the 3 quantities out of the 4 quantities. So we can solve for 4p60. So we get 8 equals 3.6 plus 4p60 times 5. We can solve for 4p60, which is 0.88. And then 1 minus 4p60, we get 4q60. And therefore, we get 4q60 equals 0.12. All right, that's it for today's video. In the next video, we will cover the Curtate future lifetime random variable. See you in the next video.